So can this line be used to calculate other things? It can actually. So another thing you're going to calculate is what happens if it is at normal pressure. So normal pressure means pressure at 1 atm. You've done this before where you've looked up some, like on those phase diagrams where you look up the pressure being 1 atm, or maybe you convert it to 760 and you go across, and the normal is the 760 where it hits the line is going to tell you your freezing point or your boiling point in this case. And so this is a different way of calculating that. So if your P is 1 atm, so we're saying your P is 1 atm. So we're saying ln of 1.0 atm is equal to negative 5188.3x plus 20.552. And what that leaves us is just one variable that lets us solve for x. Now the kind of cool thing, if you don't recognize this, when you do the ln of 1, you get 0 every time. So that makes the math kind of nice. So if we subtract 20.552 from both sides, I just get that 20.552 because this number right here had become 0. Negative 5188.3x. So then I divide my negative 20.552 divided by my 5188.3. And I get that, so I divided both sides by that. I didn't write down my negatives. My negative went away, even though my calculator is saying it's in there. I just didn't put that negative in front of that 5188 number. So I'm getting that this is negative 0.003961. You might be like, well, that doesn't look like much of a temperature. Sorry, it's positive because both theirs go away. Well, it's because x isn't x. X is 1 over t. So we're not done with our math. So then we're saying 1 over t is 0.003961. So to solve for that, we'll multiply both sides by t. And then we'll divide both sides by 0.03961. And I'll get t is equal to 1 over 0.03961. Basically, I'm just going to be taking 0, 0. I left out my extra 0. We're going to be taking the inverse of this number, if you like that kind of a thing on the calculator. So first, I'm going to actually make it positive. Oops. There we go. And then I'm going to say 1 divided by that number gives me temperature is 252 Kelvin, or if I wanted it in Celsius, minus 273.15, negative 20.7 degrees Celsius. Now let's just think and see if I did it right, because I just picked a random line with a random number. So what is that? Is that close to the normal temperature where it boils? And so I would say, no, that's nowhere near. Something's really off with my data. Your data won't be this far off, but I just wanted to use an example that would be a little bit different than the numbers that you would have. But that's how you go about solving for a temperature when you are given a pressure. The temperature should be 100 because that's the temperature at which your water boils at that pressure, at a pressure of 1.